Can you hear me? Okay. I'm going to deliver my presentation in Spanish so I can feel more comfortable to explain to you issues having to do with my region, the region of Valencia. My name is José Miguel de Paz. I work for the Andalusian Institute for Farming Research within the framework of the Institute for Sustainable Farming. And I want to speak to you about ideas I'm developing for the development of decision-making systems which deal with nitrogen in a more efficient manner in order to avoid nitrate pollution. Right, the problem with regards to nitrate pollution is not specific to a single region, but is rather affecting the whole planet, and in fact it's been included into one of the three processes affecting the planet in a manner which has been is no longer sustainable. One of them is the loss of biodiversity, and the other one is climate change, as we'll know, but the third one will be the alteration of the nitrogen cycle because of farming activities. Polluting both the atmosphere and surface and atmospheric water. And more specifically, in our region, which is in the eastern shoreline of Spain, the nitrate levels in underground waters are very high, about 50 milligrams per liter in most areas where intense farming is developed. If we look into vulnerable areas, areas vulnerable to pollution with nitrates, in the year 2000 the first official statement was made, and also the first best practices guideline was published. And the area was increased from 19% to 35%. That means that the problem is growing and is not being solved, and is being widespread to other areas in Valencia. Most of these areas, vulnerable areas, are grown with intensive crops. There are some 200,000 hectares which are right now being planted, and a more careful management of nitrogen must be taken into account in order to prevent pollution problems. And in order to enter into a more careful management of nitrogen in these areas, you should have a look at the way in which our system is put in place. There are different factors: climate, socioeconomic parameters, water use habits, and there's great heterogeneity in our area. There are dry climates, semi-dry climates, humid climate in our area. Also, the heterogeneity of soil is very big. Clay, lime, and there's organic mineral fertilization, and centralized fertilization. Social and economic factors. Farmers usually do not have a strong education, technological education. Usually they are older, they developed farming as a secondary activity, and also we have not just vegetable orchards, but also fruit tree orchards, and in terms of water, the nitrate content is also very heterogeneous. About 30% of the irrigation is being made with surface water, and there's some 70% which now uses drippers. Apart from the spatial variability, also there are complex interactions between these different environments, and this makes it for a difficult, complex system to handle. And as this complexity has not been considered, a serious of sustainability problem appear. In this case, nitrate or nitrogen pollution and the low efficiency of use in the management of nitrogen. So if we look into nitrogen efficiency, as estimated by the Ministry of Agriculture, or that I myself estimated as the paper we published in the Journal of Hydrology, we monitored the whole of the irrigated line in Valencia, we may see that the nitrogen efficiency amounts to 45-46%. So we are wasting a lot of nitrogen, which is the part polluting surface water and underground water. So if we look into the scoring as compared to other countries, we are at the tail, at the final end in terms of nitrogen management efficiency. And this because when farmers deal with nitrogen, they use fixed, stable, resilient recipes which do not take into account the conditions of their specific environment. And these fixed recipes can be taken from the good or best farming practices or from engineers. And usually organic fertilization is not considered. And this organic fertilization sometimes is doubly polluting. It's more polluting than mineral or fertilization. And in terms of the development of this decision-making model, we use the concept of specific management, tailor-made management depending on the zone. And following some of the systems, I've chosen decision-making models mingled with supporting models, and all these leads to an understanding of the complex interactions between the different factors. And also we have applied the concept of integrating mineralization of organic matter into the system. So this contribution is also be taken into account because as I said, they can be also very contaminating, very polluting. I wanted to explain to you the idea I have for the development of this decision-making system. First, these decision-making systems help us taking decisions when confronted with an unstructured problem. So scientific knowledge arranges all these for good recommendations to be made later on in terms of the application of nitrogen or other fertilizers. There's a graphical interface, a series of data, a user and a model, and if they are all put together and all that knowledge is arranged, we can end up with an adequate decision-making aid. So any user can can put forward a good recommendation. But in order to be able to develop a system of this kind, we face different problems. First, that the models are very complex and they are not adapted to the conditions of our farming system. For example, farmers do not count on the computer know-how that would let them introduce data into complex models. And also there's a problem in terms of the uncertainty on whether the right inputs are being introduced. They do not trust the system. A third problem is that usually they are unfriendly interfaces. These applications are very complex, they need a lot of information. They need some training for the farmer to be able to use the tool. So farmers in the end just discard them. And usually systems of this kind, DSSs, are not web implemented nor in smartphone applications. So the spreadability, the ability to disseminate these tools is very low. So when thinking of the development of these decision-making aid, we base ourselves in a very simple model adapted to our farming models. And it takes into account issues by low technified farmers, and at the same time systems not needing a lot of information for them to produce any informational results. Then there's the design of an intuitive, user-friendly interface, which also takes into account the preferences of farmers themselves, so they can feel more comfortable when using these tools. And also, we're talking about the uncertainty in data, that it is supported on databases, so they do not have to do many tests in the fields before using the tool. Databases in terms of climate, soil, and cultivation methods. So we have developed a web version. It's the DSS Salter Soil, which is designed for recommendations for irrigation in high salinity environments. It's quite easy to use, and it is readily available to farmers of the region of Valencia, including soil databases, climate information systems, etc. But we are talking about nitrogen, and what is it that we have done so far? We have a model, the Nutri-Soil model. It simulates the terms of the nitrogen balance in soil, also the extraction of nitrogen, the drawing of nitrogen by the plant is called a simple interface. It's supported on databases on soil, climate, etc. It's been gauged, calibrated for different crops typical of Valencia: lettuce, onion, potato, artichokes, citrus fruits, and it's been validated against leachates and increases of mineral nitrogen in soil. And it's been developed through Visual Studio for Windows, but it's been adapted for web implementation. That's our next step. Also, we have databases on more than 400 spots locations all through the irrigated area in Valencia. We have some more than 1,500 points in terms of surface waters, and also spread all through the region of Valencia. And we count on climate databases coming from 54 weather monitoring stations scattered throughout the region. Also, we count on a soil database with a series of parameters covering some 55 yearly crops and 25 fruit crops. And how is it that we're going to design this last step? First, we're going to design a graphical interface. All this side, all this initial part is designed in PHP with JavaScript. It will be a web-based interface. It will be supporting the layer to be seen, to be experienced by the farmer. Then there will be a part combining information with this other part of the graphical interface. The nature soil model is run. There will be an interpretation of the results and also decision-making algorithms for the proposal of the management of fertilizers. And there will be a part making this recommendation, filling in reports. There will be alarms, alerts, also designed through HTML for web design and PHP. This is the idea we have developed. There's a part still to be designed, and this is mostly what I wanted to let you know about.